For a long time, astronomers treated the object they called 3I Atlas as little more than a vagabond of deep space, another frozen traveler falling through the solar system on a path that meant nothing and led nowhere. It was small, it was faint, and it moved like a stone swept along the current of gravity, indifferent to anything in its way. Nothing about it suggested importance. Nothing marked it as unique. Until the numbers began to change. The earliest observations contained a whisper, almost too soft to hear, a deviation so slight that most analysts dismissed it as noise in the data. But as more measurements came in, the whisper sharpened. It refused to fade. Instead, it carved itself into a clean, undeniable pattern. The object had altered its course by around 100,000 kilometers during its swing around the Sun. This wasn't the kind of shift caused by random jets of gas or by thermal stress tearing a comet apart. It was smooth. It was directional. It pointed somewhere. And that somewhere was the edge of Jupiter's gravitational domain, the vast invisible territory where the planet's pull becomes strong enough to overshadow even the Sun's influence. An area called the Hill Sphere, an enormous cosmic harbor where objects can drift for decades, centuries, even millennia. The probability that an interstellar visitor would just happen to redirect itself toward that boundary by coincidence was so low that even the most skeptical orbital analysts felt a cold ripple run through them. The situation grew stranger when astronomers examined Atlas after its passage near the Sun. Objects of its size don't survive such encounters. They crack open like glass under a blowtorch. They break apart. They shed debris desperately trying to hold themselves together. But Atlas emerged whole. Not fractured. Not dimming. Its brightness curve didn't dip the way dying comets do. It stayed steady, almost proud, as if nothing had happened. And that became the first clue that something was wrong with the assumptions everyone had been making. If the nucleus was tiny, how had it held together? Better observations confirmed that its core was barely a kilometer across, so small it could sit comfortably inside the grounds of Vatican City. But wrapped around that minuscule core was an enormous cloud of carbon dioxide, sprawling outward for hundreds of thousands of kilometers. Comets in our solar system don't behave like this. Their comas are driven mostly by water vapor and dust, not oceans of CO2 pouring into space with steady, strangely uniform consistency. The more astronomers looked, the more they realized how much of Atlas refused to make sense. The coma was too large for the size of the nucleus. The composition too extreme for any known cometary chemistry. Even the tail was wrong, its shape, its density, the way it responded to the solar wind. It bent in ways that didn't match the models. It brightened when calculations predicted it should fade. It almost seemed to ignore the forces that control every other comet we've ever tracked. Early photographs, released late and disappointingly blurry, only deepened the mystery. The delay, partly the result of government shutdown bottlenecks, gave rise to rumors. Why had the images looked like smudges? Why had they taken so long to appear? But when powerful telescopes finally obtained usable data, there were no hidden structures, no metallic glints, nothing obviously artificial. Just that strangely small nucleus and the vast coma swallowing it like fog around a candle flame. Still, the strangeness didn't disappear. Because whatever Atlas was, it didn't behave like a fragment of ice set adrift by chance. Its motion grew increasingly deliberate as it moved away from the Sun, and every new calculation refined its path closer, not farther, from Jupiter's Hill Sphere. A trajectory this precise wasn't impossible, but it was astronomically unlikely. 1 in 26,000, according to one statistical breakdown. Not impossible, no, but suspicious enough to make even cautious scientists uncomfortable. What made the situation more unsettling was how Atlas resembled the two previous interstellar visitors. Borisov had been volatile and dusty, but still a recognizable comet. Oumuamua had been the opposite, dry, reflective, accelerating without any visible source of thrust. Atlas seemed to sit somewhere between them, part natural, part anomaly, almost as though the cosmos were presenting a sequence of questions without offering any answers. Its origin, traced loosely back toward the busy star-forming regions near the galactic core, only added to the intrigue. That part of the galaxy is a turbulent factory where stars are born close together and gravitational forces collide like tides in a storm. And that's where theories began to branch into uncomfortable territory. Because if the object wasn't following the rules of natural cometary motion, then either we were witnessing a completely new category of interstellar debris, or something else entirely. Something using comet physics as a disguise. Something that had been drifting for centuries, maybe longer, waiting for the pull of a giant planet to offer the gravitational support it needed. Jupiter, after all, is the largest gravity well in the solar system besides the Sun. It is easy to see. Easy to find. Easy to use. If anything wanted to insert itself quietly into a long-term orbit here, Jupiter would be the perfect place to do it. And the perfect braking zone would be the very edge of its hill sphere, the exact boundary Atlas seems to be aiming for now. The farther Atlas travels, the more that path narrows. And the more it narrows, the harder it becomes to explain away. The closer Atlas moves toward Jupiter's domain, the more it behaves like something following instructions rather than chance. Each new dataset reduces the margin of error in its projected encounter. It isn't drifting or wobbling as small comets normally do. Its trajectory is tightening, refining, almost as if locked onto an invisible target. Even skeptics have admitted the alignment is unnervingly precise. NASA still maintains that nothing truly supernatural or technological needs to be invoked. They point to non-gravitational accelerations, jets of CO2 blasting off the surface, as the likely cause of Atlas's course change near the Sun. But the direction of that acceleration, and the uncanny timing of it occurring while the object was hidden behind the Sun from our line of sight, leaves many uncomfortable. Outgassing is supposed to be chaotic. It's supposed to push an object unpredictably. But the force that acted on Atlas did the opposite. It nudged the path cleanly into a corridor leading straight toward Jupiter's gravitational frontier. As debates heated up, one voice drew more attention than most: Avi Loeb, a physicist known for pushing past the boundaries of comfortable astronomy. He posed a question that many found outrageous, but impossible to entirely dismiss. If this object is not acting randomly, he asked, then why Jupiter? Why aim for the one planet where an advanced civilization could hide small, passive probes indefinitely, using gravity instead of fuel? Loeb argued that if a civilization wanted to survey young star systems quietly, without revealing its presence, it might use interstellar objects as delivery vehicles, objects designed to look natural, shed no heat, emit no signals, and drift convincingly as comets until their paths carried them into a planet's gravitational architecture. There, tiny probes could be deployed into stable positions like Jupiter's Lagrange points or left to drift undetected along the boundary of the hill sphere. No energy wasted. No beacons needed. Just patience and physics. Most scientists reject this interpretation outright, but even they admit that the convergence of anomalies demands more attention than usual. Because Atlas is not strange for one reason, it is strange for many. Its composition is unusual. Its survival improbable. Its coma unprecedented in scale. Its tail non-compliant with known physics. Its acceleration too directional. And its trajectory too perfect. Meanwhile, the clock is ticking. On December 19, 2025, during a close flyby of Earth's observational window, Telescopes across the world will measure Atlas with a level of precision never before achieved. Spectrometers will probe its chemistry. Radar arrays will try to map the structure buried inside the coma. If the data shows normal cometary physics, erratic jets, mixed ices, uneven surfaces, the entire mystery could collapse into the category of extreme but natural. A rare outlier, but not impossible. But if the readings show regimented outgassing patterns or materials rarely seen in comets, or a thermal signature that doesn't match expectations, then the discussion shifts dramatically. It wouldn't prove artificiality, not immediately. But it would push the narrative away from coincidence and toward intention. And scientists know it. As Atlas draws closer to Jupiter, the tension rises. Its projected encounter, around 53 million kilometers from the planet, lies almost exactly at the Hill sphere's radius on that date. Too close not to notice. Too exact not to question. Because if nothing unusual releases from the object, we'll broaden our understanding of how interstellar comets work. But if something separates from it, even something tiny, even something we can't directly detect but can infer, then humanity will have to rewrite its place in the cosmic story. Some astronomers describe this entire situation as a crossroads. Others call it a mirror. Because Atlas forces us to confront what we believe about randomness, about cosmic silence, about whether anything or anyone might be listening or watching from distances far beyond our imagination. It challenges our instinct to explain everything through natural processes, even when those processes need to be stretched thin to cover each anomaly. And yet, the truth remains the same: we simply do not know. We don't know whether Atlas is a one-in-a-million comet forged in a bizarre corner of the galaxy or a vessel carrying something intentionally crafted. We don't know whether its precision is an illusion or a message. We don't know what, if anything, waits at the edge of Jupiter's gravitational dominion. What we do know is that Atlas has already changed the way we look at the sky. It has forced us to reconsider the possibility that the universe may communicate in ways subtle enough to pass for coincidence, at least until we look more closely. It has reminded us that mystery is not a flaw in our knowledge, it is an invitation. And so the world now watches as astronomers prepare for the final year of observations. As the countdown toward the March 2026 Jupiter encounter ticks silently forward, we stand suspended between two futures, one familiar, one unimaginable. Either outcome will reshape us. Either outcome will echo for generations. If these mysteries have captured your attention, if they've made you rethink the nature of interstellar visitors or reconsider the quietness of the cosmos, stay with the story. The next anomaly could break at any moment, and when it does, the unfolding conversation may be one of the most important our species has ever had.